Good morning everyone. Today I am going to explain about multi-vibrators. Here the main what is the definition of multi-vibrator? A multi-vibrator is an electronic circuit that is used to implement two state systems like oscillators, comma timers and flip-flops. These are the electronic circuit that is used to implement two state systems like oscillators, timers and flip-flops, and it is also characterized by two amplifying devices, that is two transistors are cross coupled by resistors or capacitors. This is the multi-vibrator. Here there is a two state systems, that is oscillators, timers and flip-flops. Here there is a two states, that is stable state and quasi stable state is used. Here multivibrators are used to generate the waveforms. Here the Henry Abraham and Eugene Blach described the first multi-vibrator circuit in 1920, also called a plate coupled multi-vibrator. Here the plate coupled multi-vibrator that can be described in 1920. It was made from vacuum tubes and its harmonics are being used to calibrate a wave meter. It was made from vacuum tube. This is made from vacuum tubes and its harmonics are being used to calibrate a wave meter. Here the classification of multivibrators. There are three types of multivibrator circuits depending on the circuit operation: astable multivibrator, monostable multivibrator, bistable multivibrator. Here the astable multivibrator, neither the state is stable, and in monostable only one of the state is stable but the other is not. In the mean monostable means, mono means single, so that here only one state is stable, other state is not. It remains in either state indefinitely. Bistable, it remains in either state. Two stable states are in the bistable. In the monostable only one stable, and in the astable there is no stable state. These are the states of the system of multi vibrator. Multi vibrators are of three types: astable, monostable and bistable. In monostable one stable state, another one quasi stable state. In bistable two stable states. In astable two quasi-stable states. Here the astable multivibrator. The astable multivibrator, a multiplier that generates square waveform without using external triggering pulse, is known as astable multivibrator. In the astable multivibrator, it will generate square waveform and there is a external triggering pulse is applied, is known as astable multivibrator. It is also known as free running multivibrator. Here this is also called as free running multivibrator. Here the input, the circuit astable multivibrator, there is a square wave. That time period is t1 and t2. Then the total cycle time period is t1 plus t2 plus vcc is the applied voltage. There is a pulse 0 and 1. It generates the square wave by using external triggering pulse. Whenever the external triggering pulse is applied, then only that will start conducting in the circuit. And the astable multivibrator, the circuit diagram of astable multivibrator consisting of the two capacitors, that is C1 and C2, two resistors RL1, four resistors RL1 and RL2 are connected across A and B, and R1 and R2 is the connected to the in between capacitors and the point A, and the collector of second transistor is connected to the base of the transistor Q1, and collector of transistor Q1 is connected to the base of the transistor Q2. There is a voltage that is VC1, that is VC1 across the voltage VC1 across the transistor Q1, the voltage VC2 across transistor Q2, and there is a supply voltage VCC. The switch S is open, and that will close depends on the applying VCC. The switch can be closed and open, and there is a charging and discharge path can be explained by using the capacitor C1 and C2, and there is a node points that can be let us taken as point A and point B. This is the stable multivibrator circuit diagram. This stable circuit consisting of two transistor, a cross coupled feedback network. Here there is a cross coupled feedback network, and two capacitors and four resistors are used in the stable multivibrator. This is the circuit diagram of the astable multivibrator. Here the astable multivibrator, first we have to consider Q1 is on condition and Q2 is off. Let us consider Q1 is on condition. Q1 means the transistor 1 is on and transistor 2 is off. The VCC drops across RL1, hence VC1 is equal to 0, and the point A is ground potential, and VC2 is equal to VCC. C1 is discharging and C2 is charging. Here the VCC drops. Here the Q1 is on means it acts as a short circuit. The point A is connected to the ground terminal, and there is a discharging path due to ground. The current will move towards the ground side. The C1 is discharging is started. Then VC1 is equal to 0, so that the discharging path is clearly indicated with the direction of the arrows. And in the second case, and the VCC is applied, so that the RL to the C1 is charging. C1 is a point is ground point, VC2 equal to VCC. C1 is discharging and C2 is charging. Here the two cases, whenever Q1 is on, Q2 is off. Here the Q2 is off means that is open circuit. The here the here the Q1 is on means it is short circuit, and Q2 is off means is open circuit. The current will move through the RL to the point B and does not go through the transistor Q2, because of the Q2 is in off condition, so that it acts as a open circuit, so that the current will move through towards the charge capacitor C2. The capacitor will charging is started, and then it will moves towards the ground terminal, that is Q1, the base of the transistor Q1 to the emitter, then it will reaches to the ground. And in the second case, Q1 is in on condition, so that it acts as a closed circuit, so that the C1 is discharges through the point A to the transistor to the ground, so that the VC1 is equal to 0, VC2 is equal to direct VCC. This is the 2 points. The VC1 is equal to 0 and VC2 is equal to VCC. This is the astable multivibrator. And second case, in the second case, uh, in the second case, in the astable multivibrator, the consider Q2 is on condition and in the second case, the Q2 is in on condition and Q1 is off condition. Here Q2 is on means it acts as a closed switch. Q1 is acts as a open switch. Here the out voltage is applied from VCC through the point the resistor through the point A. Here the Q1 is off state, so that the current will not move towards the transistor Q1. It move towards the capacitor C1, so that the capacitor C1 is charging, and it will charging towards the base of the Q2. And in the VCC is applied, here the VC2 is acts as a short circuit, so that the discharging the capacitor C2 is discharging towards the uh, point B to ground terminal. This is the case. Here the Q2 is on state, so that the ground all ground terminals are connected to the transistor Q2. Here the C1 is charging capacitor, and C2 is discharging capacitor. Whenever the VCC is applied, the switch is closed, and the current is moved through the voltage drop across RL1, that is VCC. There is a VC1 is equal to VC2 is equal to 0. VC2 is equal to 0. Here the VC1 is to voltage across the transistor Q1. That means the point A node, that voltage is VCC voltage. So that VC1 equal to VCC, up to the capacitor will charging up to VCC point. Then it will goes to the discharge through the base of the transistor Q2, and also C2 is discharging towards the point B to the ground. This is the Astable multivibrator case 2. Here the C2 is discharging, C1 is charging, VCC is drops across RL2, hence VC2 is equal to 0, and a point. Here the C2 is discharging, and C1 is the charging capacitor. Here this is the VC2. In case VCC, it will taken as the pulse, and VB2 is decreases and increases certain time. Next, the Astable multivibrator. Here the VCC acts as a pulse, and in the voltage across the base 1, first it maintains certain time, and then decreases, and it increases exponentially, and then it follows like this. And in the VC2, in the starting cycle, it will high state and then low state. And in VB2, first it will increases exponentially, then maintain constant, and then decreases and maintain exponentially. Depends on the VC2. VB2 is increases exponentially. Whenever that is in the positive off cycle, it will exponentially increases. It is in the negative off cycle, it maintains maintains constant. And in the VC1 and VB1, whenever the VC1 is the positive off cycle, VB1 is increases exponentially. And VC1 in the waveforms is taken in between VCC and time period. And the Astable multivibrator, here the Q1 is off, in the Q1 is on. Here the state in the Q1 is off, Q2 is on, that is T1 state. The time period, time constant, that is 0.69 R1 into C2, and 0.69 R2 into C2, Q1 collector and Q2 collector. The total time period is nothing but 0.669 R1C plus 0.69 R2 C1. R1 C1 is equal to R2 R1 C1 is equal to R2 C2 equal to RC. Total time constant is taken as 1.31 RC. And in the astable multivibrator, the frequency of oscillations, it can be proved that off time for q1 is t1 is for off time for q1 is t1 equal to 0.69 r1 into c2, and that for q2 is t2 equals 0.69 r2 into c1. The total time period of the wave is t equal to t1 plus t2, that is equal to 0.69 r1 c2 plus r2 c1. Here if r1 equal to r2 equal to r and c1 equal to c2 equal to c, that is the two stages are symmetrical, then t equal to 1.38 into RC. Here the frequency of oscillation we have to find time period, that is t equal to 1.38 into RC. We want frequency is equal to 1 by time period value is 1.38 into R and C. 1 by 1.38 into RC, that is equal to 0.7 by RC. This is the frequency of oscillation. Frequency means here the total time period, that is T1 and T2. Q1 is on, Q2 is on. The total time period is T1 plus T2 0.69 R1 C2 plus 0.69 R1 C1. R1 equal to R2 equal to R, C1 equal to C2 equal to C. Total terminology is taken as 2 into R into C. 2 into 0.69 means 1.38 into RC. We want frequency of oscillations. Here the frequency formula is F equal to 1 by time period, that is equal to 1 by 1.38 into RC, that equal to 0.7 by RC. This is the astable multivibrator. Here the main applications of astable multivibrators, these are mainly used in the low clock frequency clock pulse train is required. Here the low clock frequency clock pulse train is required. The pulse frequency is very low, and it mainly used in the relaxation oscillators, which are parts of relaxation oscillators means in the UJT. It acts as a relaxation oscillator, and also which are parts of vehicle indicator lights, early oscilloscopes and television receivers, and also these are mainly used in the timing signals. These are the applications where low clock frequency clock pulse train is required, and it is mainly used in the relaxation oscillator, which are parts of vehicle indicator lights, early oscilloscopes and television receivers and timing signals. These are the applications of the astable multivibrators. Here the another multivibrator is monostable multivibrator. In the meaning itself it told that mono means the single stable state, another one is the quasi stable states are used in the monostable multivibrator. Here the definition of monostable multivibrator, here the a multivibrator which has one stable state and one temporary quasi stable state. Here one stable state and another one is temporary quasi stable state, and level transition depends on external triggering pulse is known as monostable multivibrator. Here the quasi stable to stable state movement that can be depends on the external triggering pulse. This total scenario is called as monostable multivibrators. Here one stable state, another one is quasi stable. There is a change in the stable state by using external triggering pulse is known as monostable multivibrator. Here the input is T1, that is the triggering pulse is indicated like this T1, and the circuit is here the circuit is single monostable multivibrator. Here the T1 is the single pulse. Is mono means there is a single plus VCC is the applied voltage. This is the monostable multivibrator. It has one stable state and one temporary quasi-stable state. The level transition is depends only on external triggering pulse is known as monostable multivibrator. Next, here the circuit diagram of the here the circuit diagram of the monostable multivibrator. Here the extra term here, the external triggering is applied across the Q1. One external triggering circuit is used in the nearby the transistor Q1, and that is indicated with the capacitor C2, and two cross coupled transistors are used, that is Q1 and Q2. These are cross coupled transistors are used, that is Q2. And there is a VCC is the power supply. There is a S means the switch is open or closed, depends on the supply voltage, and two resistors, that is RL1 and RL2, and two resistor is R1 and R2. Total four resistors are used: RL1, RL2, R1 and R2. There is the two capacitors, that is C1 and C2. Here the external triggering circuit R3 minus VBB is connected and C2 is connected, and the two transistors are represented with Q1 and Q2. These are cross coupled transistors. There is a point A. Let us consider the point A near the Q1 point across the collector terminals of the Q1, and there is a node point, that is B, across the collector terminal of the transistor Q2. The output is taken across the point B, that is single pulse. This is the overall circuit diagram of monostable multivibrator. Here when the circuit is switched on, the transistor Q1 will be off and Q2 will be on. When the circuit is switched on, thus VCC is applied. The transistor, let us consider the transistor Q1 will be off and Q2 will be on. Here the clearly indicated in the diagram, the transistor Q1 is in the off state, Q2 is in the on state. Off state means the transistor Q1 is acts as a open circuit, transistor Q2 is acts as a closed circuit, closed switch. It acts as a closed switch. Whenever the VCC is applied and there is a VQ1 voltage, the voltage across transistor Q1 is equal to VCC. This VCC, due to this voltage, the capacitor is charges and charges through the base of the and Q2, and then reaches to the ground terminal. Here this is the case 1. This is the stable state. In the stable state, only capacitor C1 gets charged during the state. When a positive trigger is applied to the base of the transistor Q1, it turns on, which turns off the transistor Q2. When a positive trigger is applied to the base of the transistor Q1, it turns on. Here the triggering circuit is taken as R3 and C1. Whenever the triggering is applied, the positive pulse is applied across the transistor Q1, so that the non-conducting state of the Q1 is moved into the conducting state, and conducting state of Q2 is moved into the non-conducting state. Here the case 1, Q1 will be off, Q2 will be on, means it is the stable state. Here the capacitor C1 is acts as a charging. Here the capacitor is acts as the charging capacitor. Output is taken across the point B. Point B. Okay. Here in the case 2, the capacitor C1 starts discharging during this state. Here the case 1, the capacitor C1 is charged, and in the case 2, capacitor C1 starts discharging during the state, that is the transistor Q1 remains in on state. Transistor Q1 is on state due to the positive voltage from the collector of transistor Q2, which is in off state. Here the off state means it acts as a open circuit, so that the VCC is connected to the capacitor. Capacitor C1 is already charged, so that it will discharges through the point A to the transistor Q1. Transistor Q1 is acts as a short circuit. Here the transistor Q2 remains in off state until the capacitor C1 discharges completely. Here the Q2 is remains off whenever the capacitor is fully discharged and discharges through the transistor Q1. When the capacitor C1 discharged completely, when the capacitor C1 discharges completely, transistor Q2 turns on, which turns transistor Q1 off. Here the capacitor C1 is discharged completely, transistor Q2 is turns on, which turns off the Q1 off. Here the after completion complete discharging, the Q1 is goes into off state, Q1 goes into on state. This the state of capacitor discharges is called unstable state. This state is called unstable state, and whenever the pulse is positive going pulse is applied across the transistor Q2, then it will act as a on state, and it will move into the non-conducting state to the conducting state, and Q1 conducting state to the non-conducting state. Here the 4 steps are there, that is the capacitor C1 starts discharging during this state. Here the capacitor C1 is discharging, transistor Q1 remains in on state due to the positive voltage from the collector of transistor Q2 remains in on state because the VCC is applied, so that it will move to the RL2. There is a voltage drop. Q2 is off means there is no current movement to the towards the transistor Q2. The current will move towards the base of the transistor Q1, so that the Q1 is remains in the on state due to positive voltage that is from the collector of the transistor Q2, so that the Q2 which is in off state, and the transistor Q2 remains in off state until the capacitor C1 discharges completely. Next, when the capacitor C1 discharged completely, the transistor Q2 will turns on, which transistor Q1 is turns off. This is the case 2. Here the monostable multivibrator, the applications are, here the monostable multivibrator are used in analog systems to control an output signal frequency. Here the monostable multivibrator are used in analog system to control an output signal frequency. Second one, to synchronize the line and frame rate of television broadcast. Here the synchronizing the line and frame rate of television broadcast, and also to hold output voltages in its unstable state for a certain period of time. It will hold the output voltages in its unstable state for a certain period of time, and also it is mainly used in the to moderate the tunes of different actives with electronic organs. There are the main applications of monostable multivibrator. Monostable multivibrators are used in analog systems to control an output signal frequency, and also used to synchronize the line and frame rate of television broadcast, and also to hold output voltages in its unstable state for a certain period of time, and also to moderate the tunes of different actives with electronic organs. And then another multivibrator we will see, that the bistable multivibrator. Here the multivibrator that has two absolute stable states. Here the two absolute stable state. Here the meaning itself, that is bistable. Bi means two stable states multivibrator. Here the multivibrator that has two absolute stable states and can stay in one of two states indefinitely is known as bistable multivibrator. Here a multivibrator that has two absolutely stable states and can stay in one of two states indefinitely is known as bistable multivibrator. The changes it states when it gets triggering pulse. Triggering means external pulse is given and stay in that state until it gets another triggering pulse. Whenever the triggering pulse is applied, that will in the that state only. Whenever another triggering pulse is another signaling pulse is applied, then it will move to the another state. That depends on the triggering pulses. The states can be changed. The states can be changed. In that there is a input, that is a triggering of t1. There is a indicator with t1, two triggering pulses, so that the t1 pulse and t2 pulse is used, and there is a bistable circuit. Here the output is the square wave, some waveform, that is square wave T1 and T2. This is the bistable multivibrator. In bistable multivibrator, two absolutely stable state. It will move, whenever the it will triggering pulse is applied, then it will in it it is stay at only that stable state only. Whenever another external signal is applied, then it will move into the another state. The state can be depends only on external triggering pulses applied across the circuit. This is the bistable multi vibrator. Here the circuit diagram of the bistable multivibrator. Here the square wave, that is 1 volts peak to peak, 1 kilo edges. This will act as a triggering pulse for two circuits. And there is transistor Q1 and Q2. The voltage across the transistor Q1, voltage across the base to the emitter, that is VB1, and base to the emitter, that is voltage VB2. The output across VC2 is the output voltage across the transistor Q2. VC1 is the output voltage across the transistor Q1, and VCC is the applied voltage. And R1, R2 and C1 combination, R2 C1 combination, R2 C1 combination, all are connected to the two cross coupled transistors connected to the R2 C1, R2 C1, and there is a point and B point across the collector terminals of the transistors Q1 and Q2. Here the diodes D1, D2 and D3 and capacitor, these are the acts as the triggering circuits for the transistor Q2. Two triggering circuits are used in the bistable multivibrator. There is a minus VBB, means the voltage across two bases of the transistor, two bases of the transistor Q1 and Q2. This is the circuit diagram of the bistable multivibrator. Here the bistable multivibrator, when VCC is applied, one transistor will start conducting slightly more than that of the other. Let us consider here whenever VCC is applied, let us consider one transistor will start conducting slightly more than the other. Let Q be on, Q1 will off. Q2 on means the transistor Q2. Let us consider the transistor Q2 in on state and transistor Q1 in off state. Means off state means it acts as a open circuit, that is transistor Q1, and the transistor Q2 acts as a closed switch. When Q2 is on, the potential at the collector of Q2 is decreases. When the Q2 is on, the potential at the collector Q2 is decreases. Q2 is on means it acts as a closed switch, and it will decrease the potential at the base of the Q1 due to potential divider action of R1 and R2. Here the Q2 is in on state, the potential of the collector of Q2 is decreases. Q2 is in on state, potential of the collector is decreases, because that is directly connected to the ground, so that the potential is decreases, and which in turn will decrease the potential at the base of the Q1 due to potential divider action R1 and R2. And the potential at the collector of Q1 is increases, which in turn further increases the base to the emitter voltage at the base of Q2. The voltage at the collector of Q2 further decreases, which in turn further reduces the voltage at the base of the Q1. This action will continue till Q2 becomes fully saturated and Q1 becomes fully cut off. Thus, the stable state of binary is such that one device remains in cutoff and the other remains at saturation. It will be in that state until the triggering pulse is applied to it. It has two stable state. For every transition of the state, triggering is required. Triggering is required at a time only one device will be conducting. Here the Q2 will be, here in the circuit the Q2 will be on state. It acts as a closed switch. Closed switch means it acts as a closed switch and ground side, and the VCC to the point A2. Here the voltage divider network is connected, so that is directly connected to the base of the transistor until it is completely discharges. Then the Q2 will move into the off state and Q1 will move into the on state. Then the R2 C1 is considered, and then it will exercise up to the fully discharged or fully. Here the when VCC is applied, the whenever VCC is applied, the power supply is applied, one transistor will start conducting of slightly more than that of the other. Here let the transistor Q2 is on condition and Q1 is off condition. When Q2 is in on, the transistor Q2 is on, the potential at the collector of Q2 is decreases. Collector of Q2 is decreases, which in turn will decrease the potential of the base of the Q1. Here the main condition is Q2 is on condition, means the potential across the collector terminal, that is indicated some point that B is decreases, so that this point is connected to the base of the transistor of the Q1. There is a small voltage is connected across the base of the transistor of the Q1, so that the transistor Q1 is in the cutoff state, Q2 is in the Q2 is in the conducting state. That can be explained. And also here the potential divider action of R1 and R2, and the potential at the collector of Q1 is increases. Here the next case, here the Q1 is in off means here the collector potential is increases. This collector potential of the voltage that is connected to R2 C1 to the base of the transistor Q2. Here the collector voltage is increases. collector voltage increases, so that it is connected to the base of the transistor Q2, so that the Q2 is in the on state, Q1 is off state. Here that Q2 is in on state mean the collector potential is decreases, so the collector potential decreases across the transistor Q2, that potential is connected to the base of the transistor Q1, so that the Q1 transistor Q1 will move into the transistor Q1 will move into the off state. The collector of the transistor Q1 is high potential, that high potential is connected to the base of the transistor Q2. Here the total potential divider action of R1 and R2. Here the potential at the collector of Q1 is increases, which in turn further increases the, here the potential of the collector Q1 increases, which in turn further increases the base to the emitter voltage at the base of the Q2. Here the base to emitter voltage is increases at base of the Q2. The voltage at the collector of Q2 further decreases. Here the voltage is increases in that Q1 collector Q1 side, that VC1 is increases increases fastly, and here the VC2 current is decreases fastly. Here the VC2 voltage is connected to the transistor Q1. Here the VC1 voltage is connected to the transistor Q2. The voltage at the collector of Q2, here the voltage at the collector of Q2 further decreases, which in turn further reduces the voltage at the base of the Q1, so that the base voltage is suddenly further reduces, so that this action will continue till Q2 becomes fully saturated and Q1 become fully cut off. This action will continue. Here the action is VC1 is continuously increases, here the VC2 is continuously decreases. VC2 is connected to the base of the transistor Q2, and VC1 is connected to the base of the transistor Q1. VC1 is increased version is connected to the transistor Q2. There is a voltage VBE is increases across the base of the transistor, so that the Q2 transistor is in on state. Whenever the VC1 current is further decreases, the VC2 current for VC2 voltage further decreases, so that this is connected to the base. VB is also decreases, so that the transistor Q1 will in the off state only. This action will continue till Q2 becomes fully saturated. Up to this Q2 becomes fully saturated and Q1 becomes fully cut off. This action continues up to Q2 becomes fully saturated and Q1 becomes fully cut off. And thus the stable state of binary is such that one device remains in cutoff and the other device remains at saturation. Here the one device is fully move into the saturation, and another device is in the cutoff state only. It will be in that state until the triggering pulse is applied to it. It has two stable state. For every transition of state, triggering is required. Here the Q2 is fully in saturated state and Q1 is fully is in the cutoff state. Whenever the triggering pulse is applied across the transistor Q2, so that the transistor Q2 will move into the cutoff state and transistor Q1 is move into the saturation state. Here the two stable states. For every transition of states, triggering is required. Here the here we will point out this point, that is there is an important point we will remember, that is whenever every transition of states, triggering is required. Whenever the external pulse is applied across the base of the transistor, that will goes into saturation region. Another transistor will goes into cutoff state. For every transition of state, triggering is required. At a time only one device will be conducting. Here only one device is conducting, another device will move into the cutoff state. One is saturation state, another one is the cutoff state. Whenever the external triggering pulse is applied, the states can interchange. Q1 becomes saturation state and Q2 will move into the cutoff state. This is the bistable multivibrator. Here the applications of bistable multivibrators. The main applications are it is used for the performance of many digital operations such as counting and storing binary information. Here the zeros and one, and binary, in binary means two digits, that is 1 and 0, that can be stored in that by using bistable multivibrator. And also counting also possible in the bistable multivibrator. These are mainly used in the digital operations such as counting and storing binary information. And it is also used in the generation and processing of pulse type waveforms. This is mainly used for generation of the pulse type waveforms. And also it is widely used in digital logic and computer memory. These are mainly used in the digital logic and computer memory. These are the three applications that is mainly used in the digital operation such as counting and storing binary information. And also it is mainly used in the files type waveforms. And these are widely used in the digital logic and computer memory. Here this is mainly used in digital logic and computer memory. These are the three main applications in the bistable multivibrator. And this is the overall classification of the multi-stage vibrators. Here we have deal with the astable multivibrator, bistable multivibrator, and monostable multivibrators. Thank you.